Hydrogenation is the reaction of an alkene with hydrogen in the presence of catalysts such as platinum or nickel or palladium to form alkene. So, I will show you the reaction. When alkene combine with hydrogen gas in the presence of catalysts such as platinum or nickel or palladium, this reaction will produce alkene. So the double bond of alkene will break down to form alkene. For another example, when 2-methylpropene combine with hydrogen gas in the presence of catalysts such as platinum or palladium or nickel, this reaction will produce 2-methylpropene. So the double bond of 2-methylpropene will break down to form 2-methylpropene.
Halogenation of alkenes. What is halogenation? Halogenation is a chemical reaction that involves the addition of one or more halogens to a compound. In inert solvent CH2Cl2, alkene react rapidly with chlorine or bromine in CH2Cl2 at room temperature to form vicinal dihalides. So this is the formula of halogenation, which X2 is represented by halogen. So the first example is when pentene C5H10 was added to Cl2 and the product will be C5H10Cl2, which is 1,4-dichloropentane. Okay, next we will expand the formula of halogenation. This is the expanded formula for 1,4-dichloropentane. Okay, when we expand one pentane that was added into the Cl2, the double bond will disappear and two molecules of Cl was added into the formula to form 1,4-dichloropentane. Okay, now we go to example 2. So we have ethene C2H4 that was added into Br2 to produce C2H4Br2, which is called as 1,2-dibromoethane. And we will expand this formula. And when ethene that has carbon-carbon double bond was added into Br2 to produce 1,2-dibromoethane, we can see that two molecules of Br is appear and the double bond is break down.
Hydrohalogenation. Hydrohalogenation is when hydrogen halide HBr or HCl add to the double bond of alkene to form haloalkene. This is the formula for hydrohalogenation, which H(X) is represented to hydrogen halide. The first example is when propane C3H6 was added to HBr and the product will be C3H7Br, which is 2-bromopropane. Let's expand and see what happened. And HBr was added to this. The double bond will disappear and Br was added into the formula. Same goes with HCl. When HCl was added to propene, the product will be C3H7Cl, which is called 2-chloropropane. And when we expand this, the reaction will be the same as the HBr. We add HCl and the product will be like this. The double bond will untie the double bond and Cl will appear in the formula. Let's give another example of alkene, which is ethene. C2H4 added with HBr, and the product will be C2H5Br, which is 2-bromoethane. Let's expand this. Ethene has a carbon-carbon double bond, and when it was added to HBr, the double bond will untie the double bond, and it will produce this, which is 2-bromoethane.
Markovnikov rule is in the addition of HX to an alkene, the hydrogen atom add to the carbon atom of the double bond that already has the greater number of hydrogen atom. Another function of Markovnikov rule is to determine which product is major or minor. Add the example first. Okay, to make you more understand and easy to recognize the Markovnikov rule, you need to understand that halogen add to the more substitute carbon and hydrogen add to the less substitute carbon. Okay, propene add with HBr will form 2-bromopropane and 1-bromopropane. Okay, how 2-bromopropane form? Okay, we look at the carbon number 1. Carbon number 1 has more hydrogen and no substitute carbon. So, hydrogen will add to the carbon number 1. Now, we'll go to the carbon number 2. Carbon number 2 has less hydrogen and 1 substitute carbon. So, bromine will go to the carbon number 2 and form 2-bromopropane. 2-bromopropane is a major product and it follows Markovnikov rule. Next, we'll go to the 1-bromopropane. 1-bromopropane is anti-Markovnikov, and anti-Markovnikov it is opposite with Markovnikov rule. It is a minor product. Okay, how 1-bromopropane form? 1-bromopropane form when at the carbon number 1 we has more hydrogen and no substitute carbon. So, bromine will add at the carbon number 1 and carbon number 2 we have less hydrogen and 1 substitute carbon. So, hydrogen will add at the carbon number 2. So, it will become 1-bromopropane. Now, we will look at the addition of HBr to alkene in the presence of peroxide. This reaction is anti-Markovnikov. So, when propene add with HBr and has hydrogen peroxide as a catalyst, it will become 1-bromopropane.